everybody. Today we're going to be doing some practice problems with graphing exponential functions using transformations, like we have been doing in the 4.A notes. So in order to practice, you are going to need a piece of paper and a pencil. I will put a problem up on the screen. After I put the problem up, you need to pause the video and try the problem. Obviously, it is important that you actually try the problem so that you're getting practice. Then I will show the solution for the problem so you could check your work. If you got the question correct, then you can just move on to the next question. If you didn't get the question correct, then continue watching the video because I will show how we got the graph for the equation. So let's get started. So everyone should have a piece of paper and a pencil, and here's our first function that we're going to graph. We're going to graph f of x equals 2 to the x plus 3 power minus 5. Everybody, go ahead and pause your video here, and then try the problem. Okay, hopefully you tried the problem. So let's see what the new points are, and let's see what the graph looks like. So on this problem, our points on the parent function, everyone should be starting with these points. In this case, would be -1, 1/2, 0, 1, and 1, 2. Our ending points, our new points for our transformed function should be -4, -4.5, -3, -4, and -2, -3. And our asymptote on our parent function is y equals 0, and our new asymptote here is y equals -5. And here's what our graph should look like. We're just going to draw a sketch of what this would look like. So our horizontal asymptote's at y equals -5. And then here's what our graph looks like. So if you had the correct starting points, the correct ending points, and the correct graph, then move on to the next problem. If you didn't, I'm going to show you where all of those points are coming. So on any time we're doing a graphing a function with transformations, we have to have a parent function. So if I look at this function, we have f of x equals 2 to the x plus 3 power minus 5. I see that it is exponential because I have a base and an exponent. The variable is in the exponent. In this case, my base is 2 because that's the part that is raised to the exponent. So my parent function is f of x equals 2 to the x power. So when we're finding our starting points, we always use the parent function. And I use -1, 0, and 1 for my x values. To find my outputs or my y values, we're plugging these in. So here, if I'm using this parent function, f of x equals 2 to the x power. So if I plug in a -1, 2 to the -1 power, remember that's a fraction, 1 over 2 to the 1, so that gives us a 1/2. Right? If we plug in a 0, 2 to the 0 power is 1, and if we plug in a 1, 2 to the 1 power is 2. So that's how we get our starting functions, our starting point. Now we need to look at our transformations. In this case, there's two transformations here. Anything in the exponent or with the x is affecting the x values. So this x plus 3 is going to affect the x values. And remember, when something is with the x, we do the opposite operation. So to do this transformation, we would have to subtract 3 from the x values. So I'm subtracting 3 from all the x values. So my new x values would be -4, -3, and -2. So far, I haven't done anything to the y values. So my y values are still 1/2, 1, and 2. There's still one more transformation. This -5, it's not with the x. It's not in the exponent. So the only things that are affecting x will be in the exponent. Anything else is affecting the y value. So this is affecting the y value. So on this one, we're going to subtract 5 from the y values. So here, I'm doing 1/2 -5. If you don't want to deal with fractions, just use a calculator and get a decimal approximation. So I'm doing 1/2, so 1 divided by 2 in parentheses, -5 gives me -4.5. So on this one, my x values are -4, -3, and -2. And my new y values, right here, 1/2 -5 is -4.5. Right here, 1 minus 5 is -4. And then 2 minus 5 is -3. So those are the only two transformations. So these are my ending points that I'm going to use. Now, on exponential functions, we also have to take into account the asymptote. So always on the parent function, the asymptote is y equals 0 because it's always horizontal. Now, on the first transformation, this only affected the x values. So I'm not going to do anything to the asymptote because this is a y equals equation. However, on the second transformation, this one is affecting the y values. So I do also have to, I subtracted 5 from all the y values. I also have to subtract 5 from the asymptote. So my new asymptote becomes y equals -5. Right, so that's where all our coordinate points are coming from. So now let's draw those in. I always start with drawing in the asymptote. I'm going to just draw in my own coordinate plane here. I'm just going 5 in each direction since my asymptote is at y equals -5. So to draw this in, I am going to -5 on the y-axis. And when we draw in our asymptote, it's a horizontal line. That's the most common errors. People try to draw that in as a vertical line, but y equals -5 is a horizontal line. All right, and then let's put these points. So this point, -4, -4.5. Do you hear my son banging around a bunch of toys? So this point is at -4, -4.5. So left 4 and then down 4.5. Then we have a point at -3, -4. And then we have a point at -2, -3. Once we plot our 3 points, we draw them in. And this one is an exponential growth function. All right, so now let's move on to problem 2. Okay, so number 2, we're going to graph f of x equals, let's do 4 to the 2x power plus 3. All right, everyone, go ahead and pause the video here and try this practice problem. I'm going to grab my stuff. Hey, dude, what you doing? You're banging things around. All right, so let's go ahead and check the answers. Hopefully everybody tried the problem. So this time, the points on our parent function are -1, 1/4, 0, 1, and 1, 4, because this time our base is 4. Now our ending points, so our transformed points, there's two transformations here, the 2 with the x, and then the +3 is affecting the y. So my y values would actually be, or my new points would be -1/2, 3 1/4. This one would be 0, 4, and 1/2, 7. And our asymptote on our parent is y equals 0. Our asymptote on our new function is y equals 3. So if we are graphing it, here's what your graph would look like. We've got our vertical asymptote at y equals 3, and then our points would look like this. And there is our graph. So if you've got that graph, go ahead and move on to the next problem. If you didn't get that or didn't get these coordinate points, let's go through the process together. So anytime we're graphing a function using transformations, we need to know the parent function. On this one, our base, it's still exponential. We have 4 to the 2x power, and our base is 4. So our parent function is f of x equals 4 to the x power. That's the function without any transformation. So to find my starting point, I'm using -1, 0, and 1, and I'm plugging those in. So if I plug -1 into the parent function, we have 4 to the -1 power. Remember, that's a fraction. 1 over 4 to the 1, which is 1/4. If I plug in a 0, we have 4 to the 0, which is 1. And if I plug in a 1, we have 4 to the 1, which is 4. So those are our parent functions. I've got a cranky baby. Sorry, guys. So now let's do our... So the first transformation, this one has to do with x. So again, anything in the exponent is only affecting the x values. So this is affecting the x values. But remember, anything that's with the x, we do the opposite operation. So in this case, it's 2 times x. So the operation I have to do is divide the x values by 2. So I'm dividing all the x values by 2, and that's where we get our new x values. This one would be now -1/2. 0 divided by 2 is still 0, and then this one would be 1/2. And so far, I haven't done anything to my y values, so I have 1/4, 1, and 4. Next, I still have this +3 right here. That's not in the exponent, so it's not affecting the x. That means it's affecting the y. And so with y, we just do the operation we see. Here we are going to add 3 to the y values. You're okay. You're okay, puppy. So my x values are -1/2, 0, and 1/2. And my new y values, this one, 1/4 plus 3. I'm just going to write that as 3 and 1/4. Then this would be 1 plus 3 is 4. And 4 plus 3 is 7. So those are my new points. Now, are you tired? I think he's tired. All right, let's do our asymptotes and then let's graph. So our parent function always has an asymptote of y equals 0. The first operation was affecting only the x values. So it's still just y equals 0. Okay, buddy, you're okay. Almost done. Almost done. But this one, when I added 3 to the y values, it does affect the asymptote. So my new asymptote is y equals 3. All right, so these are our coordinate points. And then this is our new asymptote. So let's draw that in. So when we draw in our asymptote, make sure that you draw it in as a horizontal line. It is a horizontal asymptote. So y equals 3 is crossing the y-axis at 3. So then I'm going to draw that in as a horizontal line and then plot the points. This one, -1/2, means I go left a half, which is between the -1, 0, and -1, and then up 3 1/4, which is a little bit above my asymptote, maybe like right here. Then I have a point at 0, 4. And then I have a point at 1/2, 7. So I'm going over a half and then up 7, which is on my graph right here. And then we can draw in our graph. This one is still exponential growth because our base is greater than 1. All right, so that's what our graph looks like there.